Dear students, welcome. This is our 8th class on statics. Today we shall discuss some theorems, important theorems on statics, namely law of triangular forces, converse of triangular forces, perpendicular triangular forces, Lami's theorem, converse of Lami's theorem, polygon of forces, etc. Let me first give you the definition of law of triangular forces. Statement of law of triangular forces. Law of triangular forces. Law of triangular forces. The statement. What is the statement of the law of triangular forces? If three forces acting at a point be such that they can be represented in magnitude and direction, but not in position, by three sides of a triangle taken in order, then the three forces will be in equilibrium. If three forces, statement, what is the statement of this? If three forces acting at a point, be such that they can be represented in magnitude and direction, but not in position. If three forces acting at a point be such that they can be represented in magnitude and direction by the three sides of a triangle, taken in order, then the three forces will be in equilibrium. Then the forces are in equilibrium. Forces are in equilibrium. What is the statement of this? If three forces acting at a point be such that they can be represented in magnitude and direction, not in position, by the three sides of a triangle taken in order, then the three forces will be in equilibrium. Suppose three forces P, Q, R are acting at a point O, and they can be represented in magnitude and direction by three sides of a triangle taken in order, by three sides BCA. The proof of this theorem will be like this. Let the forces P, Q, R be acting at a point. Let us suppose that the three forces P, Q, R be represented in magnitude and direction by the sides BC, CA and AB of the triangle ABC respectively. Let us suppose that the three forces P, Q, R be represented in magnitude and direction by BC, CA and AB of the triangle ABC respectively. The three forces PQR are acting at these three forces are acting at the point O. Suppose that PQR, the three forces can be represented in magnitude and direction by the sides BC, CA and AB of the triangle ABC respectively. Of the triangle ABC respectively. Then P plus Q plus R. Then P plus Q plus R. What will be this? This is equal to P force is represented by BC plus CA plus AB. BC plus CA plus AB. BC plus CA plus AB. AB will be like this. Now BC plus CA, this BC plus CA can be replaced by BA, can be replaced by BA by factorial division. BC plus CA, this is equal to BA. This is equal to minus AB plus AB. This is equal to 0. What does it mean? P plus Q plus R equal to 0. Thus, P plus Q plus R. P plus Q plus R. This is equal to 0. P plus Q plus R equal to 0. This means that the combined effect of the forces P, Q, R is 0. Which means that the combined effect of the forces PQR is 0. Combined effect of the forces PQR is 0. This means that the forces PQR are in equilibrium. That is, the forces PQR are in equilibrium. PQ are in equilibrium. If three forces acting at a point be such that they can be represented, if they can be represented in magnitude and direction by the three sides of a triangle taken in order, then the three forces are in equilibrium. The triangle ABC is called the vector diagram or force diagram. The triangle ABC is called, number one, the triangle ABC is called vector diagram or force diagram. Number two, if P by BC equal to Q by CA, this is equal to R by AB, then also the forces PQR are in equilibrium. Then also the forces PQR are in equilibrium. Now I am going to prove the converse of this theorem. Perhaps you have understood this. Converse of this theorem. Converse of this theorem. Converse of triangular forces. Converse of triangular forces. Converse of triangular forces. converse of triangular forces. What is this? If three forces acting at a point B in equilibrium, then they can be represented in magnitude and direction by three sides of a triangle taken in order. What is the statement of this? If three forces acting at a point B in equilibrium, then they can be represented in magnitude and direction in magnitude and direction by the three sides of a triangle taken in order. What is this? If three forces acting at a point B in equilibrium, then they can be represented in magnitude and direction by the three sides of a triangle taken in order. We are going to prove the converse of the triangular forces. Let us suppose that PQR are acting at a point O. Proof of this theory. Let three forces PQR are acting at a point and is equilibrium, acting at the point O, and suppose that and is equilibrium, that is, the combined effect of PQR must be equal to 0. That is, the combined effect of P, Q and R must be equal to 0. You may write the 0 vector also. Combined effect of this is equal to 0. Suppose this force is P and this force is Q and this force is R. The three forces are acting at the point O. Now, let us represent the force P by BC and the force Q be represented by CE. Let us represent the force. The forces P and Q. Let us represent the forces P and Q by BC and CA. By BC and CA, respectively. You may write it also. Respectively, in magnitude and direction. We can represent P by BC in magnitude and direction, and we can represent Q by C. Let us represent P and Q by BC and CA. Now, since the forces are in equilibrium, therefore P plus Q plus R, the vector will be equal to 0. Now, P plus Q plus R, this is equal to 0. This means that BC plus CA, P is represented by BC plus CA plus R should be equal to 0. You may write 0 vector. 0 from BC plus CA, BC plus CA, BC plus CA should be equal to BA. Vector algebra. BC plus CA equal to BA. This is equal to minus AB plus R equal to 0. This means R vector should be equal to AB vector. This means that the vector means the force R is represented by AB. This means that the force R is represented by AB. R is represented by AB. What is this? The forces PQR can be represented by BC, CA and AB of the triangle ABC respectively. This means that the force R is represented by AB. That is, the forces P, Q and R are represented by or can be represented by, you may write can be represented by BC, CA and AB of the triangle ABC of the triangle ABC taken in order. This is the proof of the converse of the triangular forces. The forces PQ and R can be represented by BC, CA and AB of the triangle ABC taken in order. What does it mean? If three forces acting at a point are in equilibrium, then they can be represented in magnitude and direction by the three sides of a triangle taken in order. This is the converse of triangular forces. Represented by this in magnitude and direction. You may write in magnitude and direction. Not in position of the triangle ABC. Like this. It is pretty easy. Next, I am going to give you the statement of perpendicular triangular forces. 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 If three forces acting at a point be such that magnitude of each force is proportional to the sides of a triangle taken in order, and their directions are perpendicular to the corresponding sides of the triangle, then the three forces will be also in equilibrium. If three forces acting at a point be such that such that magnitude of each force is proportional to the sides of a triangle. Magnitude of each force is proportional to the sides of the triangle, and their directions. Are perpendicular to the corresponding sides. If three forces acting at the point B such that the magnitude of each force is proportional to the sides of a triangle, and their directions are perpendicular to the corresponding sides, then the forces are in equilibrium. Forces will be in equilibrium, are in equilibrium. Are in equilibrium means the combined effect of the three forces is zero. Suppose three forces PQR are acting at the point PQR are acting at the point B. Now okay, let me rewrite the diagram. Rewrite the diagram. This is suppose BCA. Rewrite the diagram. Perpendicular to this. P force. Q and R. This is force P. P is perpendicular to BC. Q is perpendicular to CA, and R. AB. Yes. Suppose three forces PQR are acting at a point O. Thus like this. Magnitude of the forces P, Q and R are proportional to BC, CA and AB of the triangle ABC respectively. Now, suppose what is the proof of this theorem? Suppose that the forces, let us suppose that the forces PQR are acting at the point O in such a way that magnitude of the forces, that the magnitude of the forces PQR are respectively proportional to the sides BC, CA and AB. It is CBCS areas. BC, CA and AB are proportional to BC. BC, CA and AB. And their directions are perpendicular to this, and their directions means the directions of P, Q and R, and their directions are perpendicular to this P force, perpendicular to BC, Q, CA and AB respectively. All inwards. In the statement of this theorem, their directions are perpendicular to corresponding sides, either all inwards or all outwards. You may write here all inwards or all outwards. BCC and AB respectively. Up to this step, perhaps it is clear. Now, let us rotate the triangle. Let us rotate BC about the point B. About the point B, let us rotate the triangle about the point B at right angle. Let us rotate the triangle ABC about the point B, anti-clockwise, let us rotate anti-clockwise through a right angle, then a new triangle A dash B C dash will be constructed. Then a new triangle A dash B C dash will be constructed. Whose directions are, you see, whose directions are parallel, whose directions are parallel to the, whose directions are parallel to the directions of the forces. Directions of the forces PQR and R. Right? What we have got? the three forces P, Q, and R can be represented in magnitude and direction by the sides B C dash, C dash A dash, and A dash B of the triangle A dash B C. This means that the forces P, Q, R, the forces P, Q, R are represented or can be represented, you may write can be represented in magnitude and direction can be represented in magnitude and directions by the sides BC dash BC dash, C dash A dash, and A dash B of the triangle A dash B C dash of the triangle A dash B C dash taken in order means that the forces P Q R are represented or can be represented in magnitude and direction by the sides B C dash, C dash A dash, and A dash B of the triangle A dash B taken in order. Therefore, by the law of triangular forces, the three forces will be in equilibrium. Therefore, by the law of triangular forces, by the law of triangular forces, the three forces will be in equilibrium. The three forces P, Q, R will be in equilibrium. What is the law of triangular forces? If three forces acting at a point be represented in magnitude, besides that it can be represented in magnitude and direction by the three sides of a triangle taken in order, then the three forces are in equilibrium. Here, the three forces P, Q, and R can be represented in magnitude and direction by the three sides, this BC dash, C dash A dash, A dash B of the triangle A dash B C dash taken in order. Therefore, by the law of triangular forces, the three forces must be in equilibrium. That is P plus Q plus R. Combined effect of the forces will be equal to 0. Combined effect of the forces will be equal to 0. Right? Now, I am going to prove a new theorem, which is called the Lami's theorem. The statement of Lami's theorem is this: if three forces acting at a point be in equilibrium, then the magnitude of each force is proportional to the sine of the angle between the other two. Let me first give you the statement of Lami's theorem, then let me try to prove Lami's theorem. Lami's theorem. The statement of Lami's theorem. Lami's theorem. If three forces acting at a point be in equilibrium, then the magnitude of each force is proportional to the sine of the angle between the other two. If three forces, the statement of Lami's theorem. If three forces acting at a point be in equilibrium. If three forces acting at a point be in equilibrium, then the magnitude of each force, then the magnitude of each force is proportional to the sine of the angle between the other two. Then the magnitude of each force is proportional to the sine of the angle between the other two. Other two forces. Suppose three forces PQR are acting at a point PQR are acting at the point O. Suppose the angle between Q and R is alpha, and R and P is beta, and it is suppose gamma. We have to show that magnitude of the force P is proportional to the sine alpha, sine of the angle between the other two. Let us suppose their proof. The proof of Laplace theorem is this. Let the forces PQR acting at the point O, be in equilibrium. That is, the combined effect of PQR should be equal to 0. Left side 0, you may write the 0 factor also. Combined effect of this is equal to 0. Let alpha, beta, gamma be the angles between Q and R, the force Q and R, comma, R and P, and P and Q, respectively. Let alpha, beta, gamma be the angles between Q and R and P and Q, respectively. Yes. Now P plus, from 1 you will get P plus Q plus R. From 1. P plus Q plus R equal to the 0 vector. This means P vector cross. Take the cross product. This means cross product is distributive. You may write like this. Zero vector. This means P cross Q plus P cross R should be equal to 0 since P cross P equal to 0. The cross product of two vectors is a vector quantity. That is why we should write here 0 vector. Up to this, now this means P plus P cross Q minus R cross P should be equal to 0. Or you may write P cross Q should be equal to R cross P, cross product. Or the magnitude, if two vectors This is a vector quantity, this is a vector quantity. Their magnitude will be also equal. Magnitude will be also equal. This means PQ, P and Q, the angle between P and Q is gamma. It will be sine gamma. Sine gamma. This is equal to RP sine beta. Sine beta. Sine beta. RP sine beta. This means Q sine gamma equal to R sine beta. This means Q by sine beta equal to R by sine gamma. Suppose this is number 2. Similarly, we can prove that P by sine alpha equal to Q by sine beta. Suppose this is number 3. From 2 and 3 we get. From 2 and 3 we get. From 2 and 3 we get P by sine alpha equal to Q by sine beta equal to R by sine gamma. What is this? From this we can conclude that if three forces acting at a point be in equilibrium, then the magnitude of each force is proportional to the sine of the angle between the other two forces. This is Lami's theorem. The converse of Lami's theorem. What is the converse of Lami's theorem? If three forces acting at a point be such that magnitude of each force is proportional to the sine of the angle between the other two forces, then the three forces will be in equilibrium. This is the converse of Lami's theorem. Converse of Lami's theorem. Converse of Lami's theorem. Of Lami's theorem. Converse of Lami's theorem. What is this? If three forces acting at a point be such that if three forces acting at a point be such that if three forces acting at a point be such that magnitude of each force is proportional to the sine of the angle between the other two. Angle between the other two. Then the three forces will be in equilibrium. Then the three forces will be in equilibrium. Three forces are in equilibrium. If three forces acting at a point be such that magnitude of each force is proportional to the sine of the angle between the other two forces, then the three forces are in equilibrium. This is the converse of Lami's theorem. Suppose I am writing here three force PQR like Q and R, this is alpha. Suppose this angle is beta and this is gamma. Let the forces PQR, let the forces PQR be acting at the point O. be acting at the point O, and at the point O, in such a way that magnitude of each force is proportional to the sine of the angle between the other two. Sine of the angle between the other two. Magnitude of each force is proportional to the sine of the angle between the other two. Let alpha, beta, gamma be the angles between the forces Q and R, semicolon, R and P, and the P and Q respectively, and P and Q respectively. Therefore, by Leibniz theory, given that, you may write here, given that P by sin alpha equal to Q by sin beta equal to R by sin gamma. This means Q by sin beta equal to R by sin gamma. This means Q sin gamma equal to R sin beta. This means P multiply both sides by P. Sin gamma equal to RP sin beta. Write like this. This means PQ, P cross Q should be equal to R cross Q. Or you may write like this. Or you may write like this. Minus P cross R vector. Or from this you may write like this. P cross Q plus P cross R equal to 0. Left side is a vector quantity, therefore you may write vector quantity. P cross P. Since the cross product of this vector equal to 0, you may write like this. This means apply the distributive law equal to 0. This means P plus Q plus R should be equal to 0. 0 vector, you may write. Since P vector is not equal to 0. P plus Q plus R equal to 0. This means that P, Q, R are in equilibrium. That is P, Q, R. Are in equilibrium. P, Q, R. P plus Q plus R equal to 0. This means that the combined effect of the forces P, Q, R is 0. Therefore, the forces are in equilibrium. Now, I am going to prove a new theorem, what is called the polygon of forces. First, polygon of forces. If a number of forces acting at a point be such that they can be represented in magnitude and direction by the sides of a closed polygon taken in order. Then the forces will be in equilibrium. Polygon of forces. If a number of forces acting at a point be such that they can be represented in magnitude and direction by the sides of a closed polygon taken in order, then the forces will be in equilibrium. Polygon of forces. If a number of forces four, 5, 6, 7 like that, if the number of forces acting at a point be such that they can be represented in magnitude and direction, can be represented in magnitude and directions by the sides of a closed polygon taken in order. Then the forces are in equilibrium. If a number of forces acting at a point be such that they can be represented in magnitude and direction by the sides of a closed polygon taken in order, then the forces will be in equilibrium. Suppose one force forces F1, F2, F3, F4, F5, F6. Suppose F6. These forces are acting at a point. These forces can be represented in magnitude and direction. Suppose this one, and also this, also this. A, B, C, D, E, F. Suppose this one, F. And F1 is represented by this, F2 is represented by this, F3 is represented by CD, F4 is represented by this, F5, and finally F6. It is a polygon. Polygon means 6 as number of sides is 6, hexagon, it will be hexagon. If the number of sides is 5, it is pentagon. Number of sides is 8, it will be octagon, like that. Suppose forces F1, F2, F3, F4, F5 and F6 are acting at the point O. Let us suppose they are proof. Let the forces F1, F2, F3, F4, F5, F6. These forces are acting at the point O. Acting at the point O. Suppose that they can be represented in magnitude and direction. Suppose that these forces F1, F2, F3, F4, F5 and F6, F5 and F6 be represented in magnitude and direction by AB, BC, CBDA, DE, CDDE, EF and FE. Be represented in magnitude and direction by this of the closed polygon ABCDEF. Of the closed polygon. You may write hexagon also. Polygon ABCDEF. EF. You may write the word respectively. Be represented in magnitude and direction by this and this respectively. You may write here respectively. AB, BC, CD, DE, EF, FA respectively of the closed polygon ABCD, EF. What is our aim? We are going to prove that the forces F1, F2, F3, F4, F5 and F6 are in equilibrium. Means F1, F2 plus F3 plus F4 plus F5 plus F6 should be equal to 0. To prove that F1 plus F2 plus F3 plus F4 plus F5 plus F6 should be equal to 0. Now F1 plus F2 plus F3 plus F4 plus F5 plus F6. This is equal to F1 means you will write AB plus F2 means BC plus CD plus DE plus EF plus FE. Now if you combine these two, AB plus BC, right? You notice here, AB plus BC, you join AC. AB plus BC should be equal to AC. AB plus BC should be equal to AC. AC plus CD plus DE plus EF plus FE. Now take a bracket here. AC plus CD. Now join AD also. You join AD also. AC plus CD should be equal to AD. AD plus DE plus EF plus FE. Just take a bracket here also. AD plus DE, just join EA. Again join EA. AD plus DE should be equal to AE plus EF plus FE. Now AE plus EF should be equal to AF. Equal to AF plus FE. This is equal to minus FE plus FE. Should be equal to 0. Equal to 0. This means that F1 plus F2 plus F3 plus F4 plus F5 plus F6 equal to 0. Combined effect of the forces is equal to 0. This means that the forces will be in equilibrium. This proves the polygon of forces. This proves the polygon of forces equal to 0. This means that this equal to 0. Means the combined effect of F1, F2, F3, F4, F5, F6 equal to 0. This means that the forces F1, F2, F3, F4, F5 and F6 are in equilibrium. What we have proved? We have proved that if a number of forces acting at a point be such that they can be represented in magnitude, direction and direction by the sides of a closed polygon taken in order, then the forces will be in equilibrium. This is the proof of polygon of forces. Dear students, I hope you have enjoyed the class. In the next class, we shall try to solve some problems. We shall use these theorems, namely Lami's theorem, law of triangular forces, law of polygon of forces, to solve some problems. Today I want to stop here. Thanks for attending the class. Thank you very much. Thank you.